Hello, welcome to more Haskell live streaming. Running a minute late, pretty shocking. So last week what did I do? I finished up adding the result type into the pipeline. So I did a bit of refactoring first, but then at the end I added the result type so that functions inside the pipeline can effectively return errors, and that will stop the rest of the pipeline from processing. So the plan for tonight, I don't really know actually. I'm not entirely sure what to do next. I'm thinking it might be quite interesting to look at adding functions to the language. So at the minute, we have a pipeline, but everything is a built-in function. But it might be interesting if we could have like a small set of built-ins and then create new functions on top of that. So I think that's what I'm going to look at tonight. I'm a little bit worried though that that might involve a lot of me swearing at megaparsec because I can't make it work, but we'll see how it goes. So I thought actually I'd start with a quick recap. But I've just noticed that this is not checked in, so I'm just going to do a bit of tidy up work first. So I have some stuff I changed at the end of last week but didn't commit, so I'm going to commit that. And I'll commit this as well. So what this is adding the result type. And push upstream. And then we'll go back to the plan. And we will open the markdown render thing. Okay. So we're at this point now where we can we got this pipeline. So we can have a function and it's you can pipe the result of this function into another function and so on. These are all built-in things. So I think what I'd be interested in doing is adding functions, or defining functions, maybe that's what it is. So to define functions, what I'm thinking of doing is we have our pipeline, so the pipeline might be something like UID, and then we pipe that into, so we'll strip out this and we will pipe it into, I can't remember what it was, we found something like truncate. And we'll truncate it to 22 characters. That was lowercase was the example I had, okay. But maybe we could define strip in some way. I don't know what the syntax for this would be like, but we could say strip is a function. I don't know why I write it in Haskell style. It's a function which will take what will it take? What's interesting actually, because there are two things to consider for the type here. One is the output from UUID, which gets passed in, and then the other one is this argument that gets passed in. So I guess this is going to be something like text, and it will also take text. So the first text is this thing, and then the second text is the output from UUID, and it returns text. We could say strip is equal to, and we could just define it in terms of a built-in called replace. So we'd replace, so it takes arguments. So we're going to replace x with nothing. So I might look at a different way to define this. So maybe we can say strip text something of text. So that's like a compile time or specified in the pipeline argument. And then we will go from this is the pipeline types, so text to text. Do we need this? I'm just wondering if we could, I don't need to write Haskell-like syntax for this. There's no reason why we do that. So we could give this argument of x, and we can say this is equal to, and then that, but actually we can get rid of this. So we can have like a syntax like that, where we have the name of the function, we have the arguments that it takes when defining the pipeline, then we have the pipeline arguments, so it goes from text input to text output, and then a definition. Yeah, let's try something like that. I don't know how easy this is going to be to parse. I guess it's going to take me all of today, and then next week we can look at maybe evaluating it. But I'm thinking, like, I quite like white space sensitive syntaxes, so maybe I'll have a go at doing that. I did open the page in megaparsec, but I've never done this before, so we'll see how easy it is to do, or I might give up. I think it's too difficult and just put braces in place. It's interesting as well because you've got definitions, I guess, separate by empty lines. And then the very last line should be the pipeline. Okay. Yeah, so I'm going to give that a go. We'll see how it goes. Who knows? So parser spec. In fact, we're going to need some extra stuff in our definition of what's inside the language. Because in the parser itself, we say an expression is either going to be a call or a pipe, but I guess we've got another thing which is now going to be a function. And the function will have some stuff. But for now, we'll have a name. Actually, it'll have a name, it'll have a list of params, and it'll have an input type, so it's a pipe, an output type, which is also pipe, and then it'll have a body, and what's inside the body? The body itself, I guess, could just be a pipeline. It's a lot of stuff, isn't it? So here we have just replace X with empty string. I guess this whole thing could be a pipeline. So you could have something which is like strip and truncate, which is just defined with something like this. Or maybe replace X with empty string and then pipe it into truncate. Okay, let's give that a go. So we need params. And what's a param? It might not be a data because it's only one constructor. So parameter is, I guess it's a pair of values. It's an identifier. And it's also a pipe for that identifier. And then we can say new type identifier. And that's just some text. And can we import pipe without getting a circular dependency? Cannot. Or at least it doesn't know where pipe comes from. Where is pipe? It's currently in the interpreter. Yes, it is. Okay. So I'll need to split that out into something somewhere different. For now, I'll just put a placeholder in there. This cannot be a new type because it's got more than one field, so it's data. And for both of these, we'll need to derive show and equals. I'm going to make these explicitly deriving from stock, and then deriving stock, oops, show and equal. Okay, and this thing also needs to derive those. Okay. So that's the type of a function. Let me just go back to the spec. I'll write up the spec for parsing something like this, and then I can get rid of this window and it'll be easier to read. So we can say describe, and where are we now? Oh, we haven't nested this at all, so we'll describe functions. And then we can say it parses a simple function, and then we can say let input equal, it's going to be this line, so it'll be strip x text, we've got type, oops, of text to text, or pipeline, a byte of text to text, and then we'll have we have a new line, and then a tab, and then replace x with leave the empty string, and then we can say parse input should be write function. That was its name of the function, so that's strip. Then the types, the two pipes we have, so we're going to go text. What was the type? What was the byte of text? It's something like, oh no, I've got a clash here of names. I need to rename that, but it's text byte. That's what we want. So that's the input and the output types, and then the definition of this is going to be a call to replace of, so the parameters to this are going to be, oh, I don't know how to do variables yet. Going to be a call to replace. We need something in here. I don't know what it's going to be, and I'll think about the arguments in a second. Right, can we make some stuff shut up? Import describe. And then we got problems function. So let me go back to parser. We're going to rename this from function to like that. Just to stop the name clash. And functions applied to 2 feet arguments. So it's the name, oh, and then the parameters. Okay. And then can we import text bytes? We probably cannot. What's up with this? I don't know why I imported it from there. That was a bit strange. That describes import list of HSpec. That's what I wanted to do. And then we could maybe try importing the interpreter. And we're just going to import Python from this, I think. It does not export it. Okay, and it doesn't know what these things are. Five network constructors. I think I can get rid of the window now. Should help. Okay, so didn't know text pipe. And that's because no idea. So text pipe is one of the constructors for pipe, which is being exported. And here we're importing it. And this is saying can match type parser.pyt with actual type pyt parser.pyt. Ah, yes. Okay. Because I did this. And I'm guessing I can't import this because this will lead to circular dependency. Okay, so I might move the pyths into their own file. So let me just quickly go to Cabal file and we'll put it into here as being an exposed module. And then in interpreter, we're going to grab the definition of this and the instance of it. And we'll move it into Python. And then we have to do some stuff. Need to import show. Okay, what else do we have for pipes? It's probably enough actually. Because interpreter can do its own, we can implement the type checking, it just can't do the type. So we can no longer export this. And that should be okay. And then now I've not got any errors on using Python. I think that comes from, what do my errors say? In the parser it's broken, but I should now be able to import this. And in the parser spec, I can't do that anymore. And now the language server has broken. Now it's still broken. Oh, because of errors somewhere else. Okay. So in the interpreter, it doesn't have Python. And void Python. And I don't know what's exhaustive. What's changed here? Let me come back to that one. And now if I restart the language server, will it be magically fixed? No, so find me the other error. It's probably because this warning is also an error. Okay. So we're importing the pipe from another file, but that's the only change we made. So we call pipe, check built-in. Oops. And then here we call go. Okay, so this, I think, is one that's broken. No. Okay, pattern match is not exhaustive. In the equation for go, patterns of type expression result are not matched. But that's not changed. I haven't changed any of this. Oh, no, we have, because we know the functions. Right, that's what it's complaining about. So we can say go function. I think it's got 4 arguments, maybe 5 arguments. We have that, and then we have the error. Okay. What's helper here? Use record patterns. I think that's kind of cool. Okay. So go back to the other error here, and we also need to do type checking on the functions as well. So it's like that, I think. Okay, we got the undefined, and then now if we restart this, failed to run it. It failed to run it because of undefined. Okay, that's getting better, I think. Right, so we can say error undefined, and then the other one we'll say error undefined. We got explicit runtime errors. Try this thing again. Okay, 3 errors now. I think that's better. Oops. Sometimes my cursor, so I type normal. There we go. Okay. Constructor not in scope. That's what I expected a while ago. So we can import the pipes. 1 error left, and that's this file, which is auto erroring. Right. Okay. Took a while. So functions. Yep. So we now expect it to match a function and return it, and I still don't know what to do with the arguments of this function. So I wonder if I can find a simpler example where we don't pass arguments in. We can just try and build it up a little bit. So we could say, I'm trying to think what we could do that would be meaningful. We could have something like ID, which is text to text, and we just alias UUID. There we go. That's a simple thing to do. So this should be ID, no arguments. It's actually a void. A void to text in this case because it doesn't take any input. So it should be void pipe to text height, and the colon here is just UID. Okay, a slightly simpler function. So now we can try to parse that, I guess. Run the tests. Right, we need a new task. Task, configure task. Create from template. Others. Test. Type of shell. Command is compile test. I haven't run these for ages, so we've got presentation. I want to say, I want the opposite of all of these usually, so we don't echo the command. We will reveal it, we won't focus it. We'll use a dedicated panel. We won't show that. And we will clear between running tests. Why not? Let's do it. Whoops. So after presentation, then we say group test. Okay, so I think I should be able to run the test now. Look at that. I can press a button on my Stream Deck and it runs a test. It's like living the dream. Cool. So it can't parse a function, which is expected because we haven't written the definition yet. Right. Okay, into the parser. How is this going to work? So it's a different function. I might rename this function again. I think the error I got from calling it function previously was misleading. But no, we have 9 errors now. Ambiguous occurrence of function. Yeah. Let's just put it back to fn because this is not going to be the most interesting thing to do today. Okay. So to parse an expression, what are we going to do? We're going to parse the functions first, and then we're going to try and parse the pipeline. So I think this is actually going to be parse pipeline. And then parse expression is going to be try to parse the functions first. So you can say many parse function. And then that's going to be followed by parsing the pipeline. That should be equals. I could start. Okay, and then parse function doesn't exist yet. So we're going to parse an expression here, but parse function. So we're going to parse for this. We're going to parse an identifier. I guess it's the first thing. Now, do we have something for identifier? Yeah, we got this. Okay, oops. Find the color of this. so we get identifier. In fact, we could just say function of that. It's not a whole function. So we will also pass in this and void pipe and another void pipe for now. And we need some kind of empty expression. So we can just put in an empty call. Okay, so we will import that. We will use the right constructor for function. And we will pure it, but we won't. Okay, not quite how this works. So parse expression runs under the parser, so we can say, actually parse identifier runs under the parser, sorry. So we can say identifier comes from parse identifier, and then we can pass it into here, and then we can say pure of that. Okay, we have a bit of a clash with ID. So we can say identifier. Right. Okay, so this is slightly wrong actually. I don't want to parse an expression, or rather I don't want the function to be intermingled with the pipeline. So actually what I want is a data pipeline, and that's going to be these. And then we will have an expression, or maybe a program. A lot of refactoring is going to be a bunch of functions followed by a bunch of functions followed by a pipeline. So program is going to be a bunch of functions. Oops, need a constructor for this. Bunch of functions followed by a pipeline. I'm going to call them fn's. And the pipeline itself is recursive, so it consists of other pipelines potentially. But is that right? Actually, I think the way we define this is actually a call followed by a pipeline. Okay, so we now need a constructor for function. Oh, sorry, a data type for function. So the function has got a bunch of arguments. I forgot what it was. It was text, and then it was a list of params, and then it was two pipes, input and output pipe, and then it's going to be a pipeline. I think makes it a bit clearer. Throw it in there. And this will also derive stock show and equal. Okay, so we've got program, which is bunch of function pipeline, then a function which consists of a name, some arguments, a couple of types, and the pipeline. parameters we don't use yet. Right. So the parser is going to give back a program. This should be actually parse program. Parsing a function is going to return a function. Parsing a pipeline is going to return a pipeline. Is there a bunch of these together? Nope. Do those. Mess that right up. What have I done? I've accidentally pasted the expression into there multiple times. Right, let's try this again. This is going to be a pipeline. And this is going to be a pipeline as well. Okay. It's going to be data because we've got 2 arguments now. We're going to export program. And now all of my tests and my interpreter are going to be completely messed up. Right. So now we're going to have a program which has got no functions and then that call. So we need to export that as well. So we'll export expressions and we might as well export the function. But expressions are not expressions anymore, they are pipelines. That's a lot of refactoring in it. Okay, so here I can say it should be a program. More brackets. Do not need more brackets. What's problem? Oh, sorry. Program initially takes the list of functions. Okay, so program list of functions, and then the pipeline. Here, same thing. So program list of functions in the pipeline. Program list of functions pipeline. Must be getting closer now. Yep. So now what we have, this is going to be a program where the list of functions is that single function. And the pipeline itself, that's going to be problematic because we need a pipeline. So our pipeline can just be ID. So our pipeline will be call ID. And that doesn't take any parameters. So can we import fn? We cannot because we're not exporting it properly. So import that and then, yep, get rid of the bracket. Okay. that's the test fixed. Now the interpreter will be an absolute mess, I guess. So we don't have expressions anymore. We have pipelines, programs, sorry. Right. Oh goodness. This is very annoying now because I'll need to rewrite this to cope with programs. So now I'm going to get rid of that for a second. So type it as to be program to input type. As a result of this, and the way programs work are you say program, then you have a list of built-in functions. So can I forget about the functions for a second? Only check the pipeline for now. So this is a program, but it's going to be in constructor it says program. We don't care about the list of functions. And then we get the pipeline. We can call that. We'll import that, and we'll import that. Okay, that helps a bit. So the type checker is given a program. It ignores the list of functions for now, because we haven't done that yet. And it just does the type checking on the pipeline. In evaluation, we can do something similar, I think. Given a program, it is going to be program. We don't care about the functions. And then we got the pipeline itself. We'll check that, and it takes a pipeline. Okay, getting better. P shadows earlier thing, right? What was P is also Pyte. So let's put us back to I call this PT. And in the parser spec, we have something. Oh, this is a parser itself, sorry. It's not the spec, so we can say parse program. Okay, so now we can say program of that. So we'll parse all our functions, we'll put them into an array of functions or list functions. We'll then join the pipeline at the end of it. I'm going to return the whole lot as a program. Okay, and parse pipe. It takes a call and a separator and then the rest of the pipeline. 2 errors to go. Let's go to that. Okay, so whoops. Import call, we'll import that. Okay, so now eval doesn't take a pipeline, it takes a program. Which we also need to import. and program takes that as an argument. There we go. What else we got? Are we good? I think we're good. Okay. Do the test run and give us the same error as before. Oh, they don't run because I broke the parser. Make it go stop. Let's just stop it. Right, back to the parser. So we need our parse function to be a bit clever because it's parsing identifier. That'll pick up anything. If I change this for a second and just say this, we'll get rid of function parsing for a second. So maybe run the tests and make sure that the previous test still, well, the test suite still works in the same way, so it parses everything except a function. Okay, that's cool. So we're not getting the function back, but the other tests do work, which is nice. Okay, so instead of doing that, we will write some better function parser. Now, to parse a function, we need to be a bit more precise. So identifier comes from parse identifier, and then we'll say pure of function identifier. This brings us back to where I was a second ago. We'll do void pipe and void pipe again. And the body of this, I just was filling with an empty call initially. Okay, and there should be many. Okay, so an identifier, but that's not all. So an identifier, then we have list of params. I'm going to get rid of params for now because I'm not going to finish it tonight. So I can get rid of this, and I now have a bunch of errors probably somewhere else. So we get rid of that. So we go identifier, and then we got a colon. So it should be character that. Is pipeline correct? Where is pipeline? Where is here? So is this correct? Yes-ish. Not great, I don't think. So pipeline is saying that a pipe consists of stuff that comes up to the pipe character and stuff that comes after the pipe character. So this is stuff before the pipe character, and this is stuff after it. And the stuff that comes before is a pipeline. And stuff that comes after is also a pipeline. Now, the way the parser works is it says the stuff on the left hand side has to be a call. So I tried to change this to be call, but call is not a type. Call is just a constructor for this pipeline. So the stuff on the left hand side of the pipe symbol is a pipeline. It's just that the parser, the way it works at the minute, forces it to just be a call. But a call is still a pipeline. And then the stuff on the right hand side, so the stuff after the pipe symbol, is also a pipeline. And that's probably going to be a call and then another pipe symbol, unless it's the last thing in the pipe. So I think pipeline is correct. I think it is. Okay. Right. Denotation discarded result of type character, but that's okay because we don't care about it. So we will just throw it away. So we go for identifier. Okay, and now we do some stuff. So we're going to skip some space. So we can say 8 space, I think. Followed by that. Why did we do space before? We just like that, okay. So we'll skip some space, potentially, doesn't really matter. Then we have a colon, and then we got some more space. So the colon, optionally, some space around the colon. Then we want to parse a couple of pipes. So we say input pipe comes from parse pipe. How is that going to work? So parse pipe is going to be a parser, and will it return a pipe? Don't see why not. Parse pipe, and what's it going to be? You know, I might just parse an identifier for now. So the way the type system works in a minute, it's either going to be a void or a text or a time, but I might want to extend that in future. So actually, I'm just going to take any identifier and we will. No, but I can't use that as a pipe. Okay, so we'll have to do something clever. So parse pipe goes from it's a parser of pipe. And it's going to be a choice. I think the choice takes a list and it takes a list of parsers. So it could be a void pipe, and that comes from the string of void. Oops, string of void. Let's have a look at this. So can we import choice? Yes, we can. And void pipe we haven't got as a constructor. Wouldn't be that though, because it doesn't make sense. Is there one of those? Yes, there is. Cool. Okay, so if we match the string void, then we return a void pipe. Text pipe, I guess, comes from the string of text. And time pipe, oops, wrong symbol there, comes from the string of time. And I can use it here. input height, and then output height. Again, we're going to parse the height. So output height. We need some space in between. So HSpace 1, actually we need more than one space. Or sorry, at least one space. Oops. And that's not right. So after the output, then we get a new line, I think. Then we get some indentation, and then we get the rest of the pipeline, like the pipeline that defines this function. So actually, I could just make this very strict. I don't need fancy parsing this. So we could say after the output type, we'll skip space. So you can have trailing spaces at the end of this. That's okay. And then we'll say we expect a character, and it should be a new line. And we're going to discard that. Actually, we get a character new line, and then we want another character, which is a tab. And then we're going to say parse pipeline. And then we can just replace this with the pipeline. If we could type properly. Okay. Use dollar. I mean, yeah, you can do, but it's gonna, I don't think it'll be easier to read. Wow. That's so much better. Well done. Okay. So in theory, that should parse stuff. Not quite. Okay, so we're going to parse the pipeline, and then we will look for a new line for any space after that. And then we will look for a new line. So I'll just put the HSpace here. Actually, I'm going to put the HSpace here. Do the same thing here. And here. And here. Not sure that's helpful. Not helpful. Okay, so we parse the identifier, we skip the colon, we parse the input height, the output height. Then we look for a new line, and then a tab. Then we parse the whole pipeline, and we look for trailing, new line. I might look for 2 trailing new lines. So we have a new line to end the pipeline, then we got a new line which is a space underneath it. And then we'll return that. So does that match our test? Just got stuck again. So here, so we have ID, some space, a colon. No, we had an arrow in between, so it wasn't just 2 types, we had the arrow. I'm going to put that back in. New line, tab, pipeline, new line, and then the whole pipeline at the end of the program. Okay, so in between these things, so the input type, own line, so we're going to go I can now make this optional space, because then we're going to say we have a string of that and then some optional space. It's okay. So now I think they should match. Let's run the test and see what happens. We have an unused import because I got rid of HBase1. Good. Not really what I expected. Whoa. Remove imports. Try to test again. 13 failures. Good. Everything is broken now. Is everything broken? What succeeded? So interpreter stuff, a couple are fine, but most of them are not because it can't parse it anymore. None of the parsing works. Okay. And that's a very unreadable error. So let's take something simple. Actually, which ones did succeed in the parser? Did they all fail? Yeah, so even like a simple call failed. I thought the definition of many would be that if this fails, it doesn't return anything. 0 or more. So given some parser, which in this case is parse function, where f is an alternative, but that is the case for parser, and a is any type. Is that right? Yeah, f goes from type to type. So we're going from nothing to function, I think. Then it returns a list of A's under that parser. So I just thought that if this doesn't match, it should be fine. But that's not the case at all. I don't want to put a try in here. Because I would have thought that if this fails, that should be okay. Once we put try in place, try fix most stuff. It just doesn't parse a function anymore. Okay, it's interesting. Can I use should parse or should be? I can't remember. No, that's not how this works. What's type of parse? either program or text. Oh, okay. Can we say temporarily, could we export parse program and call it directly? So we can say parse program input should parse that. Very upset. Okay, so boolean should parse again, and then parse program. We will import and I might bracket this. Nope. Okay, type it should parse. It takes either parse our bundle SE or A and an A and an expectation. I thought this was my expectation. Don't know what the type of expectation is here. What's the error we're getting? So we're getting something to either make a parsec bundle or program. That's what it's expecting, sorry, and it's actually getting parsec t void text entity program. It's applied to one value argument, but its type has none. But should parse those take two arguments. No. Is this just a single thing? So it should be parse function should parse input. Parse program, sorry, not parse function. No, so this is now parser, and it expects either the error or something, whatever that something is. This is annoying. Can I find something here? Should parse. Oh, parse something, something, something. Should parse whatever. Right. So parse program that and input. But I have a problem because my call to parse is probably overriding someone else's call to parse, like the built-in parsing. Um, so what's type error here? We got function parse by 3 value elements, but its type only has 1, and it's because this is the parse from my parser. But is there a built-in parse function in megaparsec? I think there is. Okay, so we can say import qualified text dot, what's it called? Text dot megaparsec. As MP. Why can't it import megaparsec? Import text of megaparsec. Oh, because in Cabal, in the test, it doesn't depend on megaparsec. Okay. So down here, I should be able to say mp.parse. Okay, and if I run it, do I get a more helpful output? What I did that for. Yes, unexpected colon. Cool. So why, I guess, is the question. So you parse identifier, which should be okay, I hope. Then we get maybe some space, and then the colon character, maybe some space. And that seems to be where it's breaking down. It's expecting double quotes, end of input, or white space. So it's not parsing the function properly. Okay, time's running on. I'm going to stop at this point, come back to it next week, see if we can fix the parser for functions. And then if we do, we can actually look at evaluating them. But yeah, I think that's enough for today. Hopefully next week we'll get beyond the parser, which is, it seems to be my nemesis, I think, writing parsers. But anyway, thanks for watching along, and yeah, hopefully see you next week. Goodbye.